Hello, ladies and gentlemen. So, in lesson 1.2, we're going to find the actual length that something is based on scale. And there's a lot of ways that you could do this. Some of them go back to things you talked about in sixth grade math. And so that's kind of what I want to review today is some of the tools that you already have in your toolbox to do this concept. So if you look at the problem on the page here, if you're not on this page, you can go ahead and pause and get here. Okay. Is you can see that there's a map and it tells you that it's a scale drawing of streets in the town, and the map on the scale from the town is 500 feet to 2 centimeters. So that means that every 500 feet in real life is going to be 2 centimeters on this map. And you can see that down here where it tells you what the scale is. It also tells you that on this little map, there's the school, and here's 3 buildings compared to the school. One is 3.5 centimeters away, 3.5. One is 4, and then one is 4.5 or 4.5 centimeters. So what we want to figure out is how far these buildings are in real life away from the school. So to figure that out, we're going to use the scale to help us. One tool that you already have in your toolbox from last year is a double number line. So that's where we're going to start. So I'm going to write on it. I'm going to right click, save to keep. Oops, going to open up in the new tab. Pick this one. Click on it until I get to the pen so I can edit the drawing. And now I'm ready to go. Okay. So on the double number line, the first thing that's been written in for you is the scale. So 2 centimeters on the map is 500 centimeters in real life. This is the first time I'm going to say this, but I'm probably going to say it to you 100 more times before we finish this here. When we are doing scale, or really lots and lots of ratios, it's going to be important for us to get down to the first where it's just a 1. Because if you have a 1, it gets a lot easier because then we just worry about the other number that's there. So if you have that 2 is 500, from 2 to get to 1, oops, I divide by 2. So from this to get to 1, I'm going to divide by 2. So 2 divided by 2 is 1. 500 divided by 2 would be 250. Okay? And if you need your calculator, put that in, by all means, use that to help you here. Once I know that 1 is 250, then it's really easy to finish the other numbers. Because if I had gone the other direction, 2 to get to 3 is times, I don't know off the top of my head. So that would have been hard. But I do know that 1 to get to 3, well, that's a pretty easy problem. So that's my advantage of going down to 1. So I'm just going to change my color here so you can see. So now I know that 1 to get to 3 is going to be times 3. So 250 to get over here is going to have to be times 3. So I keep that same relationship. And so I could type 250 times 3 into my calculator if you don't know what that is. And my answer is going to be 750. Okay? So let's try the next one then. I'm going to go change my color so that you can see what I'm doing. Let's do this. Okay? So now I have 1. I'm going to go back to 1 always when I do this. And I got 1 to 3.5 would be times 3.5. So down here I have to do 250 to here is going to be times 3.5. So again, I'm going to put it in my calculator, 250 times 3.5, and I get 875. So here I want you to try. See if you can finish this double number line without me finishing it or before I finish it. So go ahead and press pause on the video. Try to do the last three things. So what lines up with 4, what lines up with 4.5, and what lines up with 5. Press pause. Go. Okay, welcome back. Let's check, see how you did. So 4 of 4, we should have done 250 times 4, which is 1,000. For 4.5, we should have done 250 times 4.5, which is 1,125. And then for 5, we should have done 250 times 5, which is 1,250. Okay, so that was your idea there. So I'm going to go ahead then and delete this out, hit done here, copy and paste. And there's my nice thing here. I can make it a little bigger so you can see what we did. So now we could answer this question about how far things are in real life. In real life, or in the map, sorry, school to the library was 3.5 centimeters. So if I find 3.5 right here, that lined up with 875. So that means that it's 875 feet from the school to the library in real life. We could do the same thing with the train station and the town hall too. So the train station was 4, so it would be 1,000 feet in real life. And the town hall was 4.5, so it'd be 1,125 feet in real life. So double number line, one strategy, really great strategy to use to solve these problems. But we also have other strategies or tools that we can use. And one of them is the scale factor. You might have started to notice when we did the double number line that you had to keep multiplying by the same number, right? We kept doing this times 250 and this times 250 and this times 250 and this times 250 and this times 250. That 250 is a special number in scale, which is the scale factor. And so that is what we could do to figure this out on a much, without drawing out the double number line. So again, I'm going to write on this. So I'm going to right click, save to keep, open it up. And here I go. So we're going to start with scale factor in the same way that we started with the double number line. We're always trying to get down to that 1 so that then we have that 1, we can just use the other number that's there. So just like we did before, it's 2 centimeters for 500. So 2 to get to 1 is divide by 2. So I'm going to divide by 2 and I get 250. This right here is my scale factor. Okay, so 250. So in order to help us solve this problem then, we could do kind of what we did in the double number line. We just multiply each distance on the map by the scale factor, just like we were multiplying the top number times 250. So the scale factor we said was 250. So I could do 3.5 times 250, which again was 875. I could do 4 times 250. I'm trying to do the dot for multiply. I know it's a little hard to see, which was 1,000. And 4.5 times 250, which was 1,125. And of course, good mathematician, I don't want to leave these numbers naked, so I'm going to give them a label. And it was real life, so feet, feet, feet. Okay. Done. and paste there. So that's the basic idea with scale factor. So whether you set up your double number line or you use your scale factor, the key here is we're always finding what it is for 1. So one of the two numbers has to be 1. And then we can use that to multiply or to scale our way up.